Hi, and welcome to today's online SpecDD training. My name is Charles, and I'll be your instructor. Today's session, we're going to discuss requirement-driven versus requirement-first. Why we chose in SpecDD to be more requirement-driven, some of the benefits, advantages, disadvantages of both, and what exactly it means to be requirement-driven. A little bit of background first, a little bit of review for some of y'all. A spec is an abstract of a requirement, right? In SpecDD, the requirement is something that comes in the form of an epic, and it's broken down into the specs. Okay? The spec is created from these requirements. These are all really interchangeable terms, but the main issue is when we take these requirements and we move them from the requirement space to the development space, meaning when we take these requirements, specs, and we move them into our product backlog, we do not consume them. The requirement, the spec, stays in the requirement space. When we move, we actually take a copy of the spec, and that becomes our story. That becomes our instantiation of the requirement of the original spec. So we might have a spec 1, and when we move it, when we're ready to begin work, when we want to move it to the product backlog, we take an instant copy of it, and that becomes our story 1-1. Now the reason we do this is because this way we can have multiple copies of the same spec. So spec 1 could be copied to story 1-1, story 1-2, story 1-3, so on and so forth. Spec 2 can similarly be copied story 2-1, 2-2, and so forth. The requirement first methodology is more of the standard agile practice, and that is the spec is consumed. The requirement, the spec, when it moves into the product backlog, it is the item that is physically moved over into the development space. Moving into the development space, the developer, when they're actually when they're ready to work on it, they will take that original spec, begin developing on it, and thus it is quote-unquote consumed. So that's more of a requirement first idea. Now the benefit of a requirement driven, hopefully some of y'all can already name a few. The first and foremost is that because it's not consumed, the requirement details can really be updated and modified at any time. Many times the details and the information for a requirement aren't really known at the beginning, and that's very common. The spec, the customer, the stakeholder, they know what the spec is, they kind of know what they want, but the exact details are not something that they really can specify. And the developer has no idea what it is they want. So only after, when they're actually working on the item, when they're developing, when they're creating that working software via the story that comes from the spec, only then can they further define or refine the item that they're working on. And then that becomes the working software and is then passed back to the product owner, the stakeholders for review, and then they can then provide additional details as needed. So because the spec exists always in requirement, and the story is the item that's getting updated and modified in the development space, then anybody at any time can go back and update the requirement, the original spec, as needed. And this is, of course, one of the 2 deliverables for every sprint in SpecDD. You need to update the documentation. We can accept change at any point, even in the middle of a sprint. We can update, we can change the requirement, the original spec. However, the documentation, the spec, the original requirement needs to be updated. Okay? So that must happen. We allow for it, and it also must happen. Okay? So that's really the main benefit of being requirement driven. So what exactly is a story then? We have our requirement, we have our spec. Those are pretty standard terms in all agile methodologies. But what is a story? So a story is an implementation of a spec. It's an instantiation of a spec. It's a copy of a spec. A story is used to drive the implementation of the original spec. It's also used to drive the understanding of that spec. So again, we oftentimes will start something without knowing all the details. And really, it's impossible to know all the details in many cases. I want to design a new function. Does this function exist? Has it ever existed? Have I ever done anything like it? No. Then how can I possibly know every single detail that needs to be done and needs to be detailed in order for this function to be created by a developer correctly? I can't. Therefore, I start off with this story. And it may be a very basic, very generic, very undetailed story. But then when I'm developing and as I'm creating this working software and as I'm discovering things and going back and also updating the original requirement, that's how it's used. That's how a story helps with driving the understanding of the original requirement. In SpecDD, there is a small difference between story for features and stories for defect fixing. The difference, first off, is a story may not exist for defect fixing. A standalone story, in most cases, without a spec specified, without a spec linked to the story, is simply used to represent a set group of tasks. These are typically also known as defects. Can also be used for defects. So a story can be used, however, for defects if there are maybe a group of defects that have come from this iteration. There are a group of defects that pertain specifically to one story, linked to one spec. So the defects can be linked to a story, which is also linked to a spec, or it could be standalone. In SpecDD, we really allow for both because, quite honestly, both cases occur. And finally, a story is a parent of a set of grouped tasks. So if they're not defects, then they're simply grouped tasks, similar tasks that a developer has to work on. One story could spawn many tasks. So, moving on, next topic is our sprint backlog, which is essentially our workload for the specific sprint. Now this is a little different than a product backlog. Okay, in our diagrams we distinguish the two. Product backlogs feed the sprint backlog, and the sprint backlog changes with every sprint. It is by definition the workload that the developers need to finish for that particular sprint. So the sprint backlog consists of a list of stories and tasks. It's assigned from the requirement space and the product backlog, just like I mentioned. The workload percentage, though, for the sprint backlog does not include the QA child tasks. Now, if you recall, the QA child tasks are the items that the QA floaters need to be working on. These are the members that were assigned from the QA team, however, they reside within the development team in order to help with the unit testing, the small test testing the tasks that the developers are writing. So the workload percentage here does not include the QA child tasks. It basically does not include the QA floaters and their workload. Why? Good question. QA test child tasks represent the testing effort. Even though these floaters reside with the development team, these tasks represent the testing side of things. So the testing and the verifying these tasks are done with quality control, with the quality team, with the quality assurance team. Part of their job is also to create and more so to improve existing test cases. So this testing done by all these QA floaters, it's part of all the tasks, it's listed here. but there is no time remaining estimate needed. The time remaining for a QA floater task, again, is not written down, it's not recorded anywhere, and it does not add on to the time remaining that we use to calculate the burn down reports. So it is the workload of these QA floaters is not included in the sprint percentage. So here's a screenshot of our DevSuite tool within our development space. We have a specific developer highlighted here within the beta release, within sprint 1 of our beta release. So you'll see the items and the tasks that they've been tasked with. We have our hours up in the upper right for each item, and then of course who it's assigned to and a short description. You'll see some of these, like 61-1, 50-7. These are tasks that have been linked to a story. Right. And then you'll see some tasks that don't have any stories linked, okay? Such as 55, the one that's highlighted in orange here, 58, so on and so forth. So these tasks, they of course go through the typical workflow. You have them under to be assigned. Most of them are in progress. You also have some that maybe were delayed as obstacles obviously come up during the sprint, problems arise, and then you have, of course, have your closed state. So these are the tasks. These are the actual work items that developers need to work on. You'll notice that none of the QA subtasks are listed here. And again, the time remaining for those QA subtasks are not included in these tasks. They're not included in the calculations for the time remaining. They are not included in the burn down report. So what is the best way, or what are the ways to measure development productivity? So take aside the QA testing, the QA floaters, again, their time remaining, while important, is not included in this. We are simply looking for development productivity. How do we measure this? And because the QA section, because the QA floaters, their time remaining, are not included, one of the best ways to measure the productivity of a developer sprint is through the burn down chart. Not only do you measure productivity at the end with a burn down chart, it also gives you a measurement while you're in progress, while you're in the middle of the sprint. Because again, the burn down chart, as everybody knows, starts in the upper left. Everybody knows, should know by now. Burn down chart starts in the left. You have your maximum number of tasks remaining. You also have your remaining effort. And as the sprint progresses, you ideally go in a downward slope to the right. So that's the burn down chart. Another way to measure productivity is the completed number of tasks. These are denoted on this next chart by the orange. So when you first begin, of course, it's going to be 0, and then as you complete tasks on each day, hopefully more and more get completed as the sprint continues. A few other ways to measure the completed points. This is done through the velocity report, kind of a mirror image, if you will, of the burn down chart. Velocity report should be going from lower left to the upper right, in that the number of completed points is more and more as the sprint finishes. You also have your total testing effort and the number of testing failed. Now this is not the QA testing. This is the developer's own unit testing. So the time that they spent to test after they write their code and to see if anything fails, a developer needs to keep track of that. And if it's the developer that's doing it, then that is something that will be measured because it is part of the developer's productivity. And then finally, these measurements really help create a balance between a self-driving team and teams that need some sort of management. Okay? Very rarely is it one or the other exclusively. Okay? Most teams do have some sort of manager or maybe some sort of team lead, but then those leads and those managers cannot always be looking over the developers' shoulders, and nor should they be. Really don't need to micromanage your team. If you do, then you could definitely be assisted with SpecDD. In any case, the development productivity helps you measure how your team is doing and to really balance between a self-driving, they can check the progress reports, they can check all these different charts that we provide in order to self-motivate, in order to keep pushing themselves to make sure they finish on time. And at the same time, it provides managers or team leads the ability to monitor the progress as well, possibly prod a couple of developers if needed. The velocity report, as I mentioned, is one of our few cross-sprint reports. So it's simply the display of all the velocity reports across multiple sprints. As you can see here, the velocity should be around the same range, ideally. And lastly, let's finish off this session with a question. In our training poll question, what activities below will increase the time remaining of related current sprint tasks? Which one of these increase the time remaining? First choice, more QA test cases are needed for a spec with current sprint active stories. Choice number 2, a test child task failed. A test child task failed. Number 3, a task owner needs to re-implement a wrongly finished task. A task owner. Number 4, QA floater has yet to verify all test child tasks. And your 5th choice, QA regression testing cycle just started with stories being tested. Give you a chance to quickly consider those options. And let's go through them one by one. So the first choice, more QA test cases needed for a spec with current sprint active stories. This has nothing to do with the developers at all. Okay? The question is asking what will increase the time remaining for the current sprint tasks, meaning what will increase the time remaining efforts that developers estimate in their current sprint. So more QA test cases, that's something on the QA side. Second choice, a test child task failed. Again, this is something on the QA side. Whether it's a QA floater or a QA team task is irrelevant. Even if it is a QA floater and the QA floater is with the developing team and they tested this task during the sprint, even if it does fail, the time remaining for the sprint task is not increased. The task owner, number 3, needs to re-implement a wrongly finished task. The task owner, in this case being the developer, incorrectly writing code for his task, needs to re-implement the task. Sounds like we have a winner. Number 4, QA floater, yet to verify all test child tasks. Again, a QA floater, even if it is a QA floater residing with the development team, they do not increase the time remaining for developer tasks. And last but not least, QA regression testing cycle just started with stories being tested. QA regression testing has nothing to do with developers. It's part of the QA team, so therefore it has nothing to do with the time remaining of the current sprint tasks. Correct choice number 3. Okay. And for our online training, discussion, presentations, some food for thought, We won't really have a presentation for this right now, but if you could, a little exercise on your own, create a sample requirement space and a development space. Put in some requirements, some epics, some specs in the requirement space, and put in some stories for your product backlog and some development tasks for your development space. Go ahead and run through 2 sprints, populate these, and kind of use them to describe and make sure you understand the sprint process. All right. Thanks for joining in on today's session, and I'll see you next time. Goodbye.